Hello. Today we're going to be discussing section 3.5, a review of factoring. We'll start off in this video by talking about finding the GCF. We're going to discuss problems 1 through 5. When you see a polynomial and you need to factor it, there are so many different methods and it's hard to remember, what do I do? What do I do? So the first step every time is to factor out the greatest common factor. You see this huge thing, take out the GCF, then continue for the rest of your steps. All right, let's figure out how to take the GCF out. The greatest common factor of two or more monomials is the product of all their common prime factors. So let's look at problem 1 and 2 and break these down into primes. 6x cubed would be 2 times 3 times x times x times x. 4x would be 2 times x. Now, what are their common factors? 2 and x. So the product of their common factors would be 2x. The GCF of 6x cubed and 4x is 2x. Let's try problem number 2. 9 will be broken down into 3 times x, and 6x would be 2 times 3 times x. Now you find their common primes, so we have a 3 and we have an x. So the GCF of 9x squared and 6x would be 3x. All right, factor out the GCF of 6x squared y plus 14xy squared minus 42xy minus 2x squared y squared. We could take the time to break all of these down into the primes and kind of circle what they have in common, but that might take a while. Is there another way to think through the GCF? Yes. The greatest common factor is the most they can give you. So what is the most that they're all divisible by? Can I divide 14 by 6? No. Can I divide 42 by 6? Yes, but I can't divide 14, so I can't take out a 6. Can I divide everything by 2? Yes. So when you're thinking about the greatest common factor, maybe ask yourself, what can they all be divided by? All of these can be divided by 2, so they have that common factor of 2. They can't all be divided by 6, so we can't take out a 6. Every term has got to be able to give you, and they can't. So the greatest common factor when we're just looking at the numbers is 2. So I can take out a 2. What about the x's? To find the greatest common factor, it's the smallest exponent. Does every term have an x to offer me? Can they all be divided by x? Yes, 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 yes. Awesome. So I can take out an x. What about the y's? Does every term have a y they can give me? Yes, 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 yes. You're looking for the smallest exponent. Notice y to the first power and x to the first power. Those are the smallest that they all have in common. So 2x, y would be the GCF in problem number 3. Let's try it again in problem number 4. Just start with the coefficients. So 5, 10, 15. What can all three of those be divided by? And the answer is 5. Now here's another trick. If the first term is negative, factor out a negative. Here I see that negative, and I know that all three can be divided by 5, so I can factor out a negative 5. Then I look at the m's. Do all the terms have an m to give me? Yes, they do. Then you look at the smallest exponent, 1, 3, 4. He can only give me one m. I can't request more. So negative 5m is the GCF in problem number 4. Now let's look at problem number 5. That's weird. Why does it have a binomial stuck in there? This is preparing us for factoring by grouping. Notice what's common, what both terms can be divided by, is the whole binomial 2x minus 1. Can I just take out an x from both terms? No. Can I take out a 4 or a 2 from both terms? No. You cannot factor it out unless you can divide by it. So even just a 2x or just the minus 1, you can't because they're in those possessive parentheses. That's one piece. What can I divide each term by? A 2x minus 1. So I will factor out a 2x minus 1, and that is my GCF. I hope this video has helped you understand how to find the greatest common factor. We'll see you again soon for the next one.